Off the southeastern coast of Africa lies the island of Madagascar. You may know Madagascar for its exotic lemurs, but it's also home to one of the world's most colorful amphibians, the Mantella poison frog. Poison frogs aren't born poisonous, but rather they are proof of the old saying, "You are what you eat." Their toxins come from something in their diet, which is mainly ants, millipedes, and mites. But which of these small creatures is it exactly? And will a collapse in insect diversity threaten the frog's ability to survive? Meet frog expert Valerie C. Clark.
Voila. This is Mantella bacillio, a very widespread Malagasy poison frog that occurs throughout the country. This appears to be a gravid female. How do I know? Because it's just very, very fat, and this is the season for love.
Clark and her team use GPS data to alert them to the frog's location and to relay other useful information.
We're right at sea level.
They also need to collect as many small creatures as possible to try and track down exactly what these frogs are eating. They have a special system to get an idea of the local insect diversity. First, they chop up and go through piles of leaves. Then, they put the leaves in various bags, with the final plastic bag at the bottom filled with alcohol. As the soil dries out inside the first bag, the small creatures leave it to try and find wetter soil. They fall out into the plastic bag and become samples. How do you sample the toxins in a frog's skin? Well, there are a couple of methods. On this trip, Clark uses tissue soaked in alcohol to wipe the frogs' backs, so she can compare different poison frogs at different areas. But Clark also has another way of testing for these toxins outdoors, what she calls a quick lick taste test.
Let's see. Oh, it's definitely bitter.
Bitterness equals toxic. Clark assures us the poison will not affect her because Mantella are only mildly toxic to humans. They are brightly colored as a way of deterring potential predators from coming near them. The chemicals in the frog's skin may be harmful to other animals, but could be helpful to humans. Some scientists are proponents of the idea that chemicals from frogs could hold the key to new medicines, such as pain relievers and heart disease-fighting drugs.
By sampling frogs for their toxic chemicals, we're effectively taking a shortcut to the many, many chemicals that exist in countless insects in the rainforest.
Clark is committed to raising public awareness of poison frogs, like Madagascar's famous chameleons and lemurs.
I believe that they're really, really important, not only because they lead us to drugs and potential green pesticides, but also just because they're gorgeous.
Back in the village, the results are promising.
Here we go.
Clark has found a little purple millipede that has several chemicals in common with Mantella poison frogs.
This is certainly making up the great portion of the Mantella diet and has great potential to end up being some of the sources of their chemicals.
In order for the frog's toxins to work, they need a variety of small creatures to dine on, and the bigger the forest, the more small creatures to choose from. The frogs have more of these different chemicals in untouched primary rainforest. This means if the seemingly relentless destruction of the rainforest doesn't cease, there will be fewer toxic chemicals with the potential to be used in drugs.
So the more primary forest that we have, the better chance we have of finding new drug leads.
Near the end of her journey, Clark has collected a grand total of 500 tubes of small creatures. These are important clues that could lead her to some sources of the frog's toxins.
I believe that understanding factors that affect Mantella distribution is critical for designing good conservation strategies.
Clearly, she has a lot of work ahead of her, but already she is coming to one conclusion. More than ever, there is a compelling need to save the rainforest habitat. With its diversity of small creatures, if we are to save the poison frogs of Madagascar.